Hi all, my name is Gulshan Banu, working as an assistant professor, AI and DS department, SNS College of Engineering. So in the continuation of the previous video from the Unit 2 Deep Networks, today I am here to explain you next concept called as the backpropagation. We will see what is backpropagation is, the basic concepts of backpropagation. Now what is this backpropagation? Backpropagation is a process in which you have to do a checking process. Say for example, if you are having a data and you have to check the process again and again and you have to do the process based on it, it is called as a backpropagation process. Now each training example is a pair of the form x comma t, where x is the vector of the network input and t is the vector of the target. Now n is the learning rate and n1 is the number of the networks, n hidden is the number of the units in the hidden layer, n out is the number of the output units. The input from the unit 1 into unit j is denoted as xji and weights from unit 1 to j is denoted as wji. So now what is backpropagation in this? See, backpropagation in this you are having different kinds of inputs, okay, that is 1, 2 and 3. You are given with different weights. Same like that, you are given different inputs. After that, it is going to input of 4 and 5 with the different weights. After that, it is going to inputs of 6 and 7. After that, you are getting the output. Now, in this, you will be calculating the input value and also the weight and then bias. For each inputs, say for example, when you calculate input of 4, you will be calculating input into weight value, that is x of 41 comma w of 41. Okay, now next you will be calculating x of 51 comma 5 w of 51 into the different values. You will be summing up all these values, and now when you take this input 6, you will be calculating the process of input and weight, that is x of 64 comma w of 64. Now this calculation of input and weight and bias is called as the activation function. Okay, now when you are taking the input and calculating with the weight and doing the process, that it is called as the activation function. So this is the process how you will be deriving the backpropagation using stochastic gradient descent rule. Now in the stochastic gradient rule, you will be involving with d, that is descending the gradient of the error ed with respect to the single example. In other words, for each training example d, every weight wij is updated by adding it to summation value of w of ij. So these are the mathematical representation of how you will be deriving the backpropagation. Now here it has been denoted with the error value, that is ed of the error value equal to 1 by 2 summation value of tk minus ok the whole square, that is nothing but expected output minus the actual output that you are deriving. Now all these denotions are denoted as x of ji, w of ji, net of j, o of j, t of j and the sigmoidal function, that is the sigmoidal function. Okay, x of ji is the input value, w is the weight, net is the weighted sum, o of j is the output value, t of j is the target and sigmoidal functions. Okay, now you will be deriving the equation of summation values and you will be denoting it with the eta function. Okay. Okay, in this, after this you will be getting with some of the process, that is to begin. Notice the weights of wji and influence the rest of the networks only through net of j. Therefore you will be experiencing the values of minus eta summation value of the error value divided by the summation value of the net value in x of j, that is the input value. So we consider in this the case 1 where unit J is the output unit of the network, and case 2 which is nothing but unit J is the internal unit of the network. So in case 1 we will be training the rule for the output unit weights. Okay. So these are the mathematical calculations of how you will be denoting the process. First you will be calculating the summation values of error, that is output value divided by summation value of net. For that you will be having the sigmoidal function of 1 by 2 summation value of Tk minus OK. When you are deriving those equation, you will be getting the final output as minus Tj minus Oj into output value of J 1 comma output value of J. Okay. So in this case 1, these are certain kinds of values that we have derived. Now this is a solved example of how you will be having it. You will be having the weight and the input value. You will be multiplying that. Based on the multiplied value, you will be calculating the output. Now in this, see, I have explained you already like how the process is actually being executed. H of 3 will be taken into account based on the weight and the input. The weight and the input is W of I3 into X value plus W of 23 into X value. Same way, when you are calculating with the other values, you will be calculating and the output derived is 0.755. Now when you apply the sigmoidal function, you will be getting 1 divided by 1 plus e to the power minus x or minus aj, that is denoted with the given value, and when you apply the formula you will be getting 0.68. For H4 you will be getting 0.9. So based on this you will be calculating the output value, that is 0.5 minus 0.69, and therefore you get 0.19 as the output. So now in this you will be seeing like where eta is the constant called as the learning rate, and T of j is the correct teacher output for the unit, that is the actual output that you are getting, and sigmoidal function is the error measured from that. Based on this equation, when you are executing it, you will be getting certain value as minus 0.0082, and that is how you will be calculating. For each and every process you have to calculate it, that is W of 4,5, the weight of 4,5 and weight of 1,4, and based on these values you will be calculating the updated value of each process. Okay. Now this is how the actual backpropagation is being executed in the process. In the next upcoming videos we will see the other concepts that is related to the unit 2. As of now, thank you. Have a good day.